All right, number 9. We have an entire semicircle going on here that's worth 180 degrees of a full circle. They also kind of made this look far more complicated than necessary. I have to assume that they didn't intend to ask this question originally. If they're asking for the measure of angle UTW, granted, I could go down the road of solving for x and then filling in for x and combining those two angles, but if I know that this whole thing is a semicircle, I can figure out what that angle is worth by subtracting out the 78 degrees from the full 180. So 180 minus 78 equals 102 degrees. I think that was just an accident question, but in the end, technically what I could have done, had that not been what they were asking for, is I can acknowledge that all three of these, again, should add up to 180. So that's 4x minus 2 plus x plus 78 equals 180. Combine my like terms. I have 5x plus 76 equals 180. Subtract 76 from both sides. I get 5x is equal to 104. And when hold on a second. When I divide by 5, I get x is equal to 20.8, which means this angle in here is 20.8. If I substitute 20.8 in for x over there, I get an angle measure of 81.2 over here, and 81.2 plus the 20.8 gives me 102 degrees still. So it's a much longer path to finding the same answer. So it was just a silly question. Number 10. They're showing us that these two central angles are congruent. I don't care if they're in different circles, those angles are congruent, which means the arcs should match. So the arcs and the chords should also be congruent. So not only should arc CD be congruent to arc FG, but chord CD is congruent to chord FG. So 7x is equal to x squared. If I divide both sides by x, I get x equals 7. And if x is 7 and they want me to find FG, well, I plug back in. 7 squared is 49 centimeters. All right, next page. This is your last page, I believe. Yep, okay, last page, problem solving. Okay, a circle D has center at -2, -7, and it has a radius of 7. What is the measure in degrees of the major arc that passes through those points? Okay, so first thing we want to do is we want to sketch this out. So off to the side, I'm going to draw this coordinate plane, and I'm going to plot the points and kind of get a visual for what's occurring here. We're told our center, D, is located at -2, -7. We're also told that it has a radius of 7, which means it should extend 7 spots all the way around. So I'm actually going to extend on this graph here. Give myself more space to work with. Okay, so what we see is that this should go 1, 2, 3, 4, 5, 6, 7 up, 1, 2, 3, 4, 5, 6, 7 to the right, 1, 2, 3, 4, 5, 6, 7 to the left, and 1, 2, 3, 4, 5, 6, 7 down. What I can now do is I can draw a circle in, I can sketch it in. Okay, so I have my circle with a radius of 7 and -2, -7 as the radius. As the center. So what is the measure in degrees of the major arc? So we know we're talking about an arc that's greater than 180 degrees that passes through these coordinates. The coordinates are -2, 0. That's my H. Oops, my H was put in the wrong spot. My bad. Whoops. Okay, so that negative 2, 0 is this point here. That's my h. We have 5, negative 7, which is over here. That's going to be my j. And k is at negative 9, negative 7. That's this point here. And they want to know the major arc that passes through those 3 points. Not the semicircle through those points, not the minor arc through those points, but very specifically the major arc that passes through those points. So that would be connecting H to K through point J. Okay, so with that said, I'm looking at all of this. So I could realize that I'm actually dealing with 3/4 of the circle. So 3/4 of the circle is equivalent to how many degrees out of 360? Well, that's equivalent to 270 degrees out of 360. So that's going to be our answer for number 1. Number 2. A circle graph is composed of sectors with central angles that measure so on, so on, so on, and so on. What is the measure in degrees of the smallest minor arcs? Well, if I have a full circle that's split into these 4 central angles, I know that all 4 of those, 3x plus 3x plus 4x plus 5x, all 4 of those angles combined make up a full 360-degree circle. So now it's just algebra, combine like terms. On the left, we have a total of 15x. When I divide both sides by 15, I get x is 24. And then when they're asking what is the measure in degrees of the smallest minor arc, well, the smaller arcs correspond with the smaller central angles. So 24 times 3 gives me a total of 72 degrees each. Okay, number 3 and 4, the circle graph, more of this. We want to set up our proportions, right? So to find the measure of arc AB, I know that that consists of 43% of the pi. So 43% out of 100% is equal to how many degrees out of 360? Well, when I cross multiply, I find that to be 154.8 degrees. Measure of angle APC is going to be this here. So that consists of 18% and 14%. So 18 plus 14 gives me 32%. So 32% is equivalent to how many degrees? So I do my cross multiplication and I find that's equivalent to 115.2 degrees. Number 5, so close to being done, 2 more. Students were asked to name their favorite cafeteria food. The results of the survey are shown in the table. In a circle graph showing these results, which is closest to the measure of the central angle for the section representing chicken tenders? So they're not giving it to us in percent. They're not giving it to us in degrees. They're telling us the breakdown out of the full total. So how many were surveyed in total? So it's, if I add them up, we have a total of 327 people. So out of the 327 people, we're going to set up a proportion here. Representing chicken tenders. So we're looking at 75 out of the 327. So we want to know what that's equivalent to out of 360 degrees. So if I do my cross multiplication once again, I get that that's equivalent to, approximately 82.5688, etc., which means approximately 83 degrees. Last question. In the stained glass window, we are told that segment AB is congruent to segment CD. So we have congruent chords here. And then, I see there was some shifting in this setup here. Let's put things back in their place. No. Yay! So what that tells us, and they're parallel to each other, so what that tells us is that these two arcs are also congruent. So we just set up that equation. 2x plus 28 equals 4x minus 42. Subtract 2x from both sides. That gets me 28 equals 2x minus 42. I can add 42 to both sides, and that's going to get me 70 equals 2x. Divide both sides by 2, and that gets me x equals 35. And while that is a choice, be careful, because they're not asking what is x, they're asking what is the measure of CBD. So they're asking for the measure of this entire space. You need to be super careful here. As of right now, knowing x, I can find the measure of arc AB by substituting 35 in, right? 2 times 35 plus 28 tells me that up here is worth 98 degrees. If I substitute in down here, or if I trust my work and know that they should be congruent, I know that the arc down below, CD, is also going to be 98 degrees. And now, how do I figure out what these two arcs are? Well, they gave me one piece of information that comes into play. I know that the two arcs are parallel, so I know that these two arcs are going to be congruent. And I know that all the way around a circle should be 360. So what we're looking at are these two mystery arcs, plus the two arcs we do know, should combine all the way together to make a full 360 degrees. So with some algebra, I have 2x plus 196 equals 360. I can subtract the 196 from the 360, and I get 2x equals 164. Divide by 2, and I get x is equal to 82. So if each one of these is worth 82, and I know the, what am I doing? 82. And I know the arc on top is 98. Well, 82 plus 98 gives us a total of 262 degrees. Okay, if you have any questions, let me know.